Yes, good morning student. Welcome to your mathematics class. Today we will start our exercise 7.2. As we know that we have already done the exercise 7.1. Now we will continue with our next exercise, that is 7.2, that is related to the factorial. Okay, how we will solve the factorial of any number. What is the symbol of factorial? This is the notation of a factorial, or this one. Both are the notation of a factorial. Okay. For example, if I am taking the 5 factorial, then I will write 5 into 4 into 3 into 2 into 1. Okay. You will stop at the 1. It is a continuous terms, multiplication of the continuous term up to the 1. Okay. Suppose if I am taking the 7 factorial, so you will write 7 into 6 into 5 into 4 into 3 into 2 into 1. You will stop your product up to 1. Okay, reverse counting is there. Suppose you wanted to stop somewhere. ओके सपोज आप यहाँ 100 फैक्टोरियल है और आपको रास्ते में इसको पोज करना है, आप 1 तक नहीं लिखना चाहते, देन यू हैव टू स्टॉप बाय यूजिंग दैट फैक्टोरियल. ओके, you will just put the mark of the factorial on the denominator term, on the less term, and just stop the term there. So now what is the value of the 0 factorial? That is also 1, and the 1 factorial, that is also 1. The factorial is not implement for the negative numbers. Factorial of negative integers or fractions is not there, not defined. Clear? We can't solve the factorial of -1. It's not possible. Clear? Negative numbers का factorial जो है, that is not that defined. Now come to the exercise. This is the whole basic. I just take the first question. There say you have to solve that the 5 factorial plus 7 factorial, that is not equal to the 12 factorial. Firstly, you solve the 5 factorial, that is 5 into 4 into 3 into 1, and then solve the 7 factorial, that is 7, 6, 5, 4, 3, 2, 1, and the 12 factorial like this, 12, 11 into 10 into up to 1. Okay, and put all these values in the question and get your left hand side. In the left hand side you have to solve, you have to add up 5 factorial and 7 factorial. The values are already given above. You just multiply these terms and put here. Okay, and get your left hand side. And on the right hand side there is a 12 factorial. You will observe that the sum of these two factorials are not equal to this one. Okay, it's just a simple question. It's based on only on calculation. Come to the next question, where you will have that the question number 2, 8 factorial by 4 factorial, that is not equal to 2 factorial. Clear? So I will solve 8 into 7 into 8 factorial, and in the denominator there is a 4 factorial. So I will stop at the up to the 4 factorial. 8, 7, 6, 5, and the 4 factorial is there. In the denominator there is a 4 factorial, that will be cancelled, and multiply these terms and get your answer. 8 7 5, 56 into 30. You will have 1680, and on the right hand side you will have the 2 factorial, that is 2 into 1, it's 2. Either you can check that these value have the value, these term have the value 1680. These value have the 1680, and the right hand side having the 2, which is not equal. Clear? So it's proved here. Come to the next question, question number 3. In the question number 3, you have to solve the lot of terms. I am taking only the 3 part of this, and plus 3 factorial by n factorial. which term is larger here? That is n plus 3. So you will minimize these terms. Then 1 less, n plus 2, again 1 less, n plus 1, again 1 less, that is n, and you have to stop here. So I am applying the factorial, and in the denominator there is n factorial, that will be cancelled. So you will get this sum. Clear? Come to the next question. There is the sixth part is also there. 6 factorial into 1 into 3 into 5 dot 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 11, that is the odd numbers, and 2 power 6. How you will solve it there? 6 factorial, 6, 5, 4, 3, 2, 1. Clear? And again there is a 1 into 3 into 5 into 7 into 9 into 11, and there is a 2 power 3, 6, that is 2 into 2 into 2 into 2 into 2 into 2. 6 times I am writing the 2. Now you have to make the continuous series of natural numbers. I start 1 to 6 is there. 1, 2, 3, 4, 5, 6. 7 I am getting from here. There is the 8. These all 3 terms multiply making the 8. Now I need the 10. So pick 5 into 2. That's it. Sorry, firstly I need the 9. That is as it is. Then I need 10. And 11 is there. I am writing directly 11. Now in the continuous term, the last term should be 12. 3 4s are 12. And no term is left here. So there is a continuous series of the natural number up to 12. So if I wanted to write in the terms of a factorial, so I will write the 12 factorial, the largest number. If you have the series up to the from starting from 1 to up to the highest number, so we will use as a that the factorial of that highest number. Clear? Come to the next question. Question number 4. The question number 4, I am taking the second part of this one. 1 into 3 into, there is all the odd numbers. Dot up to the 2 and minus 1. Okay, and to make this series complete, so I need the all the even numbers. So we need the product of even number, that is 2, 4, 6 up to the last one is 2n, because 2 and minus 1 is there. So this is the odd number. So there the consecutive greater even number will be 2n. Clear? So I am multiplying with this term. So I have to divide with this term also. 2. Now in the numerator part, the series is totally prepared. First is here, second is here, 3, 4, 5, 6, 7, 8, 9, 10. And which is the largest number? So I just put the factorial there. As you can see that the largest number is 2n or 2n minus 1. 2n is the largest number, so I will put that 2n factorial here. And what about the numerator? So you can easily observe that the 2 is factor of the each term, 2 into 1. So I will write 2 into 2, 2 into 3, or last is 2 into n. So in each term I am having the 2. So I will write it. 2 is multiplication of these two for the n times. I will write 2 power n. So there is 1 into 2 into 3 up to n. So now the series is completed up to the n. So I will write as n factorial. So this is the answer of this question. Come to the next question. Next question is question number 5. That is just a basic question. I am just taking the second part. You have to evaluate n factorial by r factorial into n minus r factorial when the values of n and r is already given. The value of n is 15 and value of r is 12. So put the values here. 15 factorial by 12 factorial and n minus r, that 15 minus 12, that will become the 3 factorial. So if I am just observing the denominator term, there is a 12 factorials, and if I am just going to compare with the numerator, so there is a 15 factorial is greater than the 12 factorial, so I will just this factorial. 12 for 15 into 14, 13 into 12 factorial. I will pause up to the 12. So in the denominator there is a 12 factorial and I will resolve the 3 into 2 into 1, that is the 3 factorial. Clear? So 12 factorial will be cancelled directly. 3 5s are 15, 2 7s are. Now multiply these terms and get your answer. 91 into 5, so you will have 455. Come to the next question. Question number 6 is just like the question number 4, second part. You just try by yourself and then reply. Come to the question number 7. There is n minus 1, n minus 2 up to the n minus r plus 1. And on the right hand side you have n factorial by n minus r factorial. I am taking the right hand side here. As you can easily observe that n factorial and n minus r, which is the greater than term, so that I can sort out that factorial. N is the greater one, so I will sort it and writing in the descending order n minus 1, n minus 2 up to where I will stop. In the series of these terms, I definitely have the lesser term, that is the n minus r. In the denominator, I am having n minus r factorial, so I am just stopped at the n minus r term. So I will write here n minus r factorial. As you can see that when I am just going to write in the decreasing order, so each term, first term is greater than the next term. Here, this is the greater than by 1, this is also greater by 1. So if I stop, pause here, I stop in this factorial, so I will definitely have a one more term, one greater term, that is n minus 1 plus 1, n minus r plus 1. So n minus r factorial will be cancelled. So I will have here n minus 1, n minus 2 and up to last term is n minus r plus 1. So this is our left side and hence proof. Clear? Come to the next question. Now I am taking the question number 9, that is n minus 1 factorial by n minus r minus 1 factorial plus r into n minus 1 factorial divided by n minus r factorial, and on the right hand side I am having n factorial by n minus r factorial. Clear? If I am just going, these are not able to comparable, but these terms are comparable. Okay, this is the factorial of n minus r and this is the factorial of n minus r minus 1. Which is the greater one, so that I can sort out that factorial. So this is the greater. Okay, and this both the terms are same. So firstly I will take the common n minus r, n minus 1 factorial. I am taking common from these two terms. So I am having here n minus r minus 1 factorial here plus r. 1 is there because I have taken the common that term. Then n minus r minus n minus r factorial. Now I am just going to sort out this factorial because this is the greater than this one. So I will write this term and then multiply n minus r minus 1 less term. Okay, so now it's become the same. So I will take this common also, that n minus 1 factorial, and in denominator I am taking common n minus r minus 1 factorial. Then what I have here in the bracket, 1 by 1 plus r is there, and in denominator I am having n minus r. Now you have to take the LCM only, n minus r. Now I am having n minus r plus r is there. R will be cancelled. So n minus 1, that is the common part, n minus r minus 1 factorial. When I am just going to write these two terms, I am having n into n minus 1 factorial. And in numerator I am having n minus r into n minus r plus 1 factorial. Is it clear? So now as you can see that this is the greater term from this one, before the factorial, so the factorial will shift to the greater term, that is the n factorial if they are consecutive. अगर यहाँ कोई दो consecutive है, suppose this is the 10 and this is the 9 factorial, so 10 into 9 factorial means the 10 factorial. The factorial will shift from the lesser term to the greater one. Okay, one greater term. So I just shift the factorial up to the higher term, that is the n. And in the same way, the factorial will be shift. Here is n minus 1. This is the one lesser term from n minus half. So the factorial will shift from the greater term, that is n minus half factorial, which is here right hand side. Hence true. Clear? So in this way you will try this exercise and we will take the doubt in the next class. Okay? Thank you.